Okay, and I know you'd probably like more time on these, but I gave these to the kids a bit ago to work on. The blue one's totally different than the red one. I'm going to start with the red one, and I got to go kind of fast, so if you need to watch this review video later to see how this worked, that would be okay. All right, if I put in a 0 into this equation to find the r so that we could graph it, if I put a 0 here, I got to figure out sine of 0. That's its own little separate problem. So I'm going to go off and draw a little picture and try to figure out where sine of 0 is. Sine of 0. Well, this is where 0 degrees is. And, oh, this is the kind where you don't have a triangle. So I have to remember that sine is y, cosine is x, and tangent's y over x. Okay, some people talking right now? Not a good idea. I'll get grouchy with you. Thank you. All right, so the sine is the y, and the y is this, and so that's 0. And so this part's 0. 2 times 0 is 0. 1 minus 0 is 1, so r must be 1. Raise your hand if you guys had 1 for that first one. Okay, good. Would you read them down, please, Mr. ML, for these first 5 answers? Tell me what you had. 1 minus the square root of 2. Raise your hand if you guys had the same thing for that. Okay, that's must be, well, I don't know. One person had that. 2 people had that? Okay. I'm going to check that one through quick. Okay, square root of 4. I'm going to put into this equation the square root, sorry, pi over 4. So pi over 4 goes in here. Now I got to figure out, it's a separate little question. What is the sine of pi over 4? So I'm going to go over here. And it's very possible that you're right, but a lot of people are having it wrong if you are right. Sine is opposite over hypotenuse, okay, and if this is the pi over 4 triangle, it's the 45, 45, 90, which is the 1, 1, root 2. And sine is opposite over hypotenuse. Opposite over hypotenuse. I'm getting 1 over root 2 for this part. So I'm going to go 1 minus 2 times 1 over root 2. All right. So then, oh, I bet I know what's going on. I bet some people simplified it different than other people did. 1 minus 2 over root 2 would have been okay. How many of you had that? Okay, there's nothing wrong with this then. How could that be right and this also be right? If you rationalize that denominator, you multiply it by root 2 over root 2, do you get that you would get 2 root 2 over 2, which cancels and becomes just root 2? That is equal to root 2. We have practiced that before, that rationalizing denominators thing. Now, it's not like his answer is better. Either answer is fine. 1 minus 2 over root 2 or 1 minus root 2. All right. So, since you got that one right, you just had it written differently. Could you continue with your answers? 1 minus the square root of 3, and I get that's the same, probably the same kind of a thing, where you probably rationalize the denominator, which is cool, but some people might not have. What is it if it's not rationalized? 1 minus, is it 1 over root 3? Oh, 3 over square root of 3. Okay. So if you didn't have this, but you had 3 over square root of 3, that'd be okay. All right, next one. The one with pi over 2, sir? Negative 1. Can anybody verify negative 1 on that one? Okay, good. And the last one. Positive 1. How many of you guys had positive 1 for the last one? Okay, good. All right, then your only challenge from there would be, could you graph all of those things? Now this, if this were a test question, and we do have something where you have to listen to what I'm about to say, you haven't got a calculator for this part, and therefore, you're not going to know exactly what these decimals are, but you have to be able to kind of estimate them. If you have 1 minus the square root of 2, you have to be able to say, okay, that's like 1 minus 1 point something. So then my answer, at least you would need to know that the answer would be negative. All right. All right, next, let's go back to our blue problem, which was 2 a.m. it was 40, 11 a.m. it was 20. sinusoidal, except we always use cosine. Because that way, the distance to here, the x value of that, again, that's the time in this case, will be our shift. All right? The amplitude is that number that comes from the number that runs right down the middle. What's exactly between 40 and 20? Hopefully you knew this was 30. Right? All right. And then the amplitude is from 30 to 40, and that would make it 10. How many had the right amplitude in there? Okay, good. So y equals 10 cosine of, and now for this next part, for b, this b term that goes right here, I need a formula. The period is 2 pi over b. Is this one of the ones that actually uses 2 pi? Cosine doesn't use 2 pi? What I'm trying to say is my formula right? Yes, my formula is right. I'm using 2 pi because it's cosine. What if we were trying to do this in tangent? We would have had to use a period of pi. Okay, so back to this formula is right, and I get you misunderstood my question, some of you. Yeah, we're going to have a new period. It's not 2 pi anymore because we get our period from this 2 a.m. to 11 a.m. deal. How many hours is it between 2 a.m. and 11 a.m.? 9 hours. But we don't say the period's 9 hours. 9 hours is half of the period, so we double it and make it 18. How many of you used 18 for your period? Good. Then we're going to solve for b, and when we switch those b and the 18 around, we end up with b equals 2 pi over 18, which reduces to pi over 9. Okay, and that's the b term. And then we have theta minus how far are we shifted? How far do we shift it? 2, because from here to here, this is where our axis would be. It got 2 a.m. compared to midnight. This is always where we consider the starting point. It was shifted 2. So there you go, shifted 2. Because the peak here, if this is really cosine, that peak should be right here. And so how far has it been shifted? All right. And then the last but not least is where we say this whole thing has been moved up 30 because that dotted line is up 30. So we put a plus 30 at the end of our equation. Okay, that's all the time I can devote to that. R equals 2 sine theta. Convert that, which is in polar, to rectangular. I'll pause for a second while you do that. Okay, now, you should start by multiplying by r on both sides. Why? Because if you square both sides, it's just going to be really icky. It's not like it's illegal, but it's a lot easier to do this. Did any of you see why? R squared is simple now, right? What's R squared? X squared plus Y squared. And now I'm getting it converted over, but if I leave this having an R in it, I won't be done. It'll be half polar and half rectangular. So how do I get that switched? You got to remember that R sine theta is actually what? Y. So this is 2y. All right, that is the equation for the original red equation, r equals 2 sine theta. It's this in rectangular. Now, I know some of you are like, that doesn't look right. Well, it's because it's not solved nicely with all of its y's in one place and stuff. But we don't usually make you solve for anything. Now, if we do, we'll say solve for y or solve for x. And from here, you just have to solve for whatever they say to solve for. Okay? Let's do another one that's similar to that. Let's see, wait. There. What if I wanted that to be converted to polar? Because right now it's rectangular. Think about those equations that we're working with and which ones we could swap out for which ones. And pause for a minute while you change that over to polar. Okay, did you figure out that it would be smart to get x squared and y squared together on the same side? That would be smart. X squared, I'm going to add y squared to both sides. And that way I have x squared plus y squared together. Why? Because then I can swap those out for an r squared. It equals 7. I moved the 7 to the right-hand side. I hope I didn't do too many steps at once there. Okay? That's how you'd kind of normally write a circle with a radius of not a nice radius, but what is the radius of this guy? Square root of 7. If you just know what you're looking at, then you could just jump to this. Boom. That's how you write a polar with that radius, right? If I know this is a circle with a radius of square root of 7, then I can just go, boom, that's polar. Okay, now, a little slower way to do it would have been replace this with r squared. R squared equals 7. And then that's just, from there, just solving for r. Excuse me, you're packing up a smidge early there, sir. We got like 5 minutes left, so just hold on. See, once somebody starts snapping their iPad shut, everybody wants to leave. And we're not ready yet. Okay, so we have one more that I want to talk through with you. Pausing for a second. Yes, the intersection kind. So let's say I say r equals 2, and I have another equation like r equals 5 plus 3 sine theta. How do I know where those two things intersect? Well, I told you yesterday you could either graph them both, which would be a real pain without a calculator, and see where they intersect. Or you could put the one equation into the other equation. Do substitution, that's called. So would you please just do the substitution part and then solve for, get it down to sine theta equals something. Do the substitution and then solve it down so sine theta equals something. And then you'll be able to find the angle. Except I'm going to probably want to make this easier because we have very little time left. So I'm going to pause for a second. Let me try that. Okay, since r equals 2, you put a 2 right here. Then I'm going to subtract 5 from both sides. I have negative 3 equals 3 sine theta. And then divide by 3, and I have sine theta equals negative 1. Now, here's the thing. People think you're used to that other kind where you're like, you're done if you changed it from x and y's into polar. Well, it's not done. Because I need to know where do they intersect. They intersect at a point. What is that point? Well, what is sine theta equals negative 1? Where is y negative 1? Down here. So what is that answer? Are we in inverse trig where it's going to be a negative angle? No, we're not doing inverse trig right now. So where's that spot? 3 pi over 2. So then sine of theta tells me that theta must be 3 pi over 2. But what's the r? I mean, okay, so that's the angle, but we need an r comma theta. Then, if you want to know the actual point where they intersect, you've got to put this back in here and solve for r. Do you get? Now, I've got a simple answer, though. In this case, it's really easy because, think about it, r is 2. It says r is 2. So if I got to make a point where these guys cross, and it's got to be r comma theta, doesn't it have to be r equals 2? Comma, theta is 3 pi over 2. All right, so I know all of you could have gotten to this point, but to get the point where they cross, remember you need an r and a theta. And if we told you what r is up here, don't go brain dead and think, I can't figure out where they r is 2. It says that right there. And the theta was right there. All right. As always, there's a lot of homework problems with answer keys worked out. I would go do practice problems. I would do one similar to what we just worked on just now. Have a great day. Be ready for tomorrow.